there is an application of combinations known as Bernoulli experiments. And the way it works, a Bernoulli experiment question is kind of like this. I have a coin. This is a biased coin. Easier to understand, actually, with a biased coin. So most coins are 50-50, heads and tails, one half, one half. This coin comes up heads 3/5 of the time, and tails the rest 2/5 of the time. No edge on this one. And the way a Bernoulli experiment question goes is, if I flip this coin, I tell you how many times, so 5 times. What is the probability that I get exactly that? You get exactly 2 heads. Implied in that is that the rest of them would have to be tails. So the way this works is, first of all, a little bit about probability. The probability of getting 5 heads in a row would be very unlikely. In probability, when things are independent, which coin tosses are, you can multiply them together, the probabilities together, to get the probability of both things, or in this case 5 things happening. So it would be 3/5 times 3/5 times 3/5 times 3/5 times 3/5, otherwise known as 3/5 to the 5th power, which is about 8%. So the chances of getting 5 heads when you flip it 5 times is pretty low. The probability of getting 2 heads and 3 tails is actually higher than that. But the probability of getting 2 heads in a row, followed by 3 tails in a row, is actually, in this order, heads, heads, tails, 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 would be 2/5 times 2/5, 3/5 times 3/5 times 2/5 times 2/5 times 2/5, which is actually smaller. It's only about 2%, 2.3% more accurate. So in that sense, it looks like it's more likely to get 5 heads than to get 2 heads and 3 tails. But there are other ways to get 2 heads and 3 tails, like heads, tails, heads, tails, tails. Well, the probability of that happening is 3/5 times 2/5 times 3/5 times 2/5 times 2/5, which is also 2.3%. I'm going to write both of these as 3/5 squared times 2/5 to the 3rd. Now there are other ways to get 2 heads and 3 tails, and they're all going to be this thing that's about 2.3%. So the probability of getting 2 heads and 3 tails is going to be 2.3% times the number of ways to get 2 heads and 3 tails. Well, that comes from the last lesson. If there are sort of 5 coin tosses that are going to happen, I want to pick 2 of them to be heads. In other words, 5C2 is equal to 10. So the answer to this question is 10 times 2.3%, which is about 23%. The official formula is for R successes in n trials, if probability of success is equal to what's called P, it's going to be NCR times P to the R power. Now if the probability of success is 3/5, failure is 2/5, it's always 1 minus P. So this is the official formula for the probability for Bernoulli trial. For the example we just did, it was 5C3 times 5C2, times 3/5 to the 2nd times 2/5 to the 3rd. These two numbers always add up to 1. These two numbers always add up to whatever this number is, and these two numbers match. Sometimes instead of asking what's the probability of getting exactly this many successes, they'll say here, so now I have 10 coins. What's the probability? They'll make fair coins. What's the probability of getting at least 7 heads? So for this one, it's actually 4 questions in one. It's probability of getting exactly 7 or 8 or 9 or 10. You have to add those 4 things together. Well, 7 coins is 10c7 times 1/2 to the 7th times 1/2 to the 3rd. 8 is 10c8 times 1/2 to the 8th, 1/2 to the 2nd. 9 is 10c9 times 1/2 to the 9th times 1/2 to the 1st. And 10 is 10c10 times 1/2 to the 10th times 1/2 to the 0. And when you put these things all together, you actually get 1024 in the denominator. I think the numerator becomes 176, and the whole answer becomes about 17%. Sometimes they'll say what's the probability of at most. So if it was at most 3 heads, I would do probability of 0 heads plus probability of 1 heads plus probability of 2 heads. If they said more than 7 heads, I would just do 8, 9, and 10. If they said less than 3 heads, I would do 0 and 1. And one other thing to mention, what's the probability of at least 1 head? So we could do probability of 1 plus probability of 2 all the way up to probability 10, but that would be a lot of adding. So the sneaky trick is to do it indirectly. The probability of getting 0 is 10c0, 1/2 to the 0, 1/2 to the 10th, which is 1 over 1024. So at least 1, you could do 1 minus the probability of 0 and get 1023 over 1024. That's called indirect probability, where you do, instead of calculating the probability exactly directly, you do 1 minus the probability of it not happening. Okay, so that takes care of Bernoulli experiments, or Bernoulli probability, sometimes called binomial probability.